Good morning, everyone. Welcome to 2.2, Angles Formed by Parallel Lines. Let's begin. We're going to start with three different and very important definitions. The first one is vertically opposite angles. Okay? Vertically opposite angles are intersecting lines that cross each other. The point where they intersect is called the vertex. The opposite x angles are equal. Okay? So I'm going to demonstrate vertically opposite angles. Vertically opposite angles are like angle B and angle E and angle B. Okay, those two are vertically opposite. They intersect at the vertex, which would be right here. Okay, so then, the vertically opposite angles are equal. Therefore, angle E equals angle B. As you can see, by the same token then, angle A also equals angle F. So they are also vertically opposite. The same holds true down here. Angle C equals angle G. And angle H equals angle D. All right? So, those are vertically opposite angles. The next one is alternate exterior angles. These are two non-adjacent exterior angles formed between two lines and a transversal on opposite sides of the transversal. These angles are also equal. So, if you remember from 2.1, we talked about interior angles and exterior angles. Exterior are the ones outside the box, EF and HG. Those are the angles we're going to be looking at right now. We are looking for angles that are on the opposite sides of the transversal between two parallel lines. So angle E is equal to angle G, because they are alternate exterior angles. Angle E equals angle G. There's one more set of alternate exterior angles, which are right here. Angle F equals angle H. On opposite sides of the transversal, these angles are also equal. So angle F equals angle H. The third and final one is alternate interior angles. These are two non-adjacent interior angles formed between two lines in the transversal on opposite sides of the transversal. These angles are also equal. So in this case, we're looking at the inside angles now, not the exterior, but the interior. Again, on the opposite side of the transversal, so angle A equals angle D, and angle, different color here, angle B equals angle C, as they are alternate interior angles. Okay. Next up. So here's an example. We're going to put these rules into action here. So we are given one angle. We're given that this angle at the bottom here is 110 degrees. And from that, we are asked to find the angles for A, B, C, and D. Let's give that a try. So there's a number of ways you can attack these questions. There's no right or wrong way. As long as you're following the rules, it's fine. So the first one that pops out to me is that this 110 corresponds with angle A, because they are corresponding angles. At the same time, you also, if you didn't want to do it that way, you could say that angle 110 and angle B are alternate exterior angles. Both are true, and whichever method you use to solve it is up to you. So we'll use the alternate exterior. So these two angles are equal, so this has to be 110 degrees. Now, if that is 110 degrees, then we know that B and A are vertically opposite angles, and vertically opposite angles are also equal. So if B is 110, A is 110 as well. Okay? The next thing that I see is that angle A and angle C, right here, these two form a straight line, right? And we know that a straight line has to be 180 degrees. So angle A and angle C have to equal 180 degrees. It's called same side interior angles. Same side interior angles have to add up to 180 degrees. So if angle A is 110 plus C equals 180, we solve for C, we get C is 70 degrees. So this is 70 degrees. And if we know that C is 70 degrees, then that means that D also has to be 70 degrees, as they are alternate interior angles. So this one is 70 as well. Okay? It's important to repeat the rules as you're solving them to help them stick in your mind. Next question. Occasionally, you are asked to prove that something that you might know to be true. So we know, obviously, that angle E equals angle G because they are alternate exterior angles, but sometimes they want you to prove it and they want you to give reasons for it. And that could be something like this. The first thing I would say, if I have to prove that angle E equals angle G, I could start by saying that I know that angle E equals angle C, so I could say angle E equals angle C because they are corresponding angles. Corresponding angles making the same shape. Then I also know that angle C equals angle G. Angle C equals angle G as they are vertically opposite. Therefore, if angle C equals angle E and angle C also equals angle G, therefore that means that angle E equals angle G. And that's called the transitive property, right? If A equals B and B equals C, then obviously A equals C. So in this case, this proves that angle E is equal to angle G. In this case, we are asked to solve for x. So we have our diagram here, which is a fairly standard diagram to use in a lot of these questions. On the top, we've got 3x plus 10, and on the bottom, we've got 6x minus 14. And we are asked to prove or to solve for x. So when I attempt a question like this, I'm looking for angle properties that'll help me solve it. And I see that these are alternate exterior angles. And we know that alternate exterior angles are equal. Therefore, 3x plus 10 equals 6x minus 14, because these are alternate exterior angles. So now it's just a matter of solving for x. So I can minus 6x from both sides. Negative 3x plus 10 equals negative 14. Minus 10 from both sides. Oops. Negative 3x equals negative 24. Divide both sides by negative 3. X equals 8. So the value of x is 8. That brings us to the end of today's assignment or examples. There are a number of questions due on page 78, and if you need some additional practice, there are questions on page 84 and 85. Thank you. Have a good day.